Hello everyone. Today's problem looks innocent at first glance. Just a parabola, a circle, and a question about the chord of a parabola. This is one of those questions where algebra alone is not enough. We need concepts, geometry, and a bit of visual intuition. We are given a parabola, you can see in the question, and a circle, and they intersect at 2 points A and B. The task is to find the focal chord length, the length of the focal chord AB of the parabola. So before just starting from anywhere to solve the question, now pause for a moment and think carefully. What exactly is a focal chord? How does the focus of the parabola control its geometry? Means what are related properties? And why does the circle's equation matter so much here? So in this video, I will solve this problem in two completely different ways. First, by transforming the geometry into algebra, which is the natural way of starting the solution of problems of such kind. This method may be lengthy, but worth going through. Secondly, using pure analytical geometry, carefully applying the definitions, the properties of focus of the parabola, and chord geometry of parabola and circle both. Finally, we visualize the entire situation using GeoGebra so we can see what's really happening instead of guessing. We will not just calculate, we will try to understand how the parabola sits in the coordinate plane with the circle and how the circle cuts it, and why the focal chord length comes out the way it does. This problem beautifully connects algebra, geometry, and visualization, and is very challenging to design such kind of question. Anyway, this problem beautifully connects algebra, geometry, and visualization, as I said. And this is exactly the kind of thinking competitive exams love to test. So don't rush. Let us slow down, draw it, feel the geometry, and then solve it elegantly and insightfully. Let's begin. Alright, so this parabola and circle intersect each other at A and B. So one natural way to do is what? The natural way, we can think that we will try to solve the equation and find out the values of x and y, and so identify A and B, which is going to be a focal chord of the parabola, and then we will find length by distance formula. Or the natural way we can think. If you think smartly, natural way also, one can think that, okay, why not I can take the parametric point of the parabola and substitute in the circle equation, so that we have an equation in terms of only one variable, that is t as a parameter, and we will solve that. So suppose you want to take it, so the x you write t plus at square, at, and y is equal to 2 plus 2at. Why I am taking this thing? Because you notice that this parabola is shifted parabola. It means the parabola vertex is at now 3, 2. It means that so you want to visualize this entire scenario, the parabola shifted at 3, and it's horizontally open rightward, and you notice that the a value is 4 into 4. A value is 4 here, If you try to use this thing, even if you just get this value a here, so what do you get? The x value. X value is 3 plus 4t square, and the y value is 2 plus 8t. And now the turn is to substitute this value x and y in this giant equation of the circle. So of course, nobody will like it because x will be 3 plus 4 square the whole square, y is equal to 8t whole square, and so on. But if you are patient enough to do this kind of calculation, you will do it. The answer will come in a very natural way. Instead, what we can do better. So this thing we don't like. We don't like this kind of thing, and we move forward. What we move forward? We think in a different way. Why not we can shift the entire system to the origin? It means we want to shift the parabola vertex at the origin. In this process, what will happen that the circle is also going to shift together with the parabola correspondingly. It means we are shifting the entire intersection of the parabola and the circle, and this will not change the required answer. Why will not change? Because we are actually considering the length, or we are into finding out the length of the chord. So until any dilation is happening, or any change is happening in the shape of the parabola or circle, or both, the length of the chord will not change. And if you're shifting the entire system to the origin, the length will never change. So first takeaway is that if they give this kind of question and they're asking for the length of anything geometrically, we can shift for our convenience, and we can still find out the length what is required. So what we can do better is this one. So the better approach is this. So better what we can do that I'm shifting that y is and x is. How do we shift it? I need to change this vertex x minus 3 and y minus 2 to the origin. Now the place of x, what you substitute to get it the feeling of y square is equal to 16x, it is of course x plus 3. As soon as you substitute x plus 3, you get this is x, and this you shift y plus 2. So our parabola P, the transformed parabola, will turn into y square is equal to 16x. But the same shift you have to give to the circle. So circle, what we can do? For the circle, similar shift I have to do. Circle C, at the place of y, I'm going to substitute y plus 2. At the place of x, I'm going to substitute x plus 3. Let's do it. So x plus 3, the whole square, plus y plus 2 whole square, minus 35x plus 3, minus 7y plus 2, plus 106 is equal to 0. And let's simplify it and see how this circle will help us. Now we further simplify it. So we get x squared plus y squared, and here you get plus 6x minus 30 plus 4y minus 7. Together. Here I'm getting 30, because 3 square plus 4 square. 3 square plus 4 square is in here. And this is minus 35 times minus 105 minus 1 minus. You can notice this whole thing will get cancelled altogether, because 106 minus 1 minus 30 minus 14 minus. So this will turn into a circle which is the easier one to guess, where it is. This is 6x minus 35, that is minus 20, and this is minus 3. So this is a circle passing origin, and it is easy now to have. So we now have the parabola y square is equal to, and so I can take the parametric equation of the parametric x is 80 square, that is 40 square, y is 280. So that now our plan is very simple. What is the plan? Plan is like, I have a parabola. Let's say I have a parabola like this. It is not straight. And I have a parabola like this. This vertex is now at origin. And there's a circle, the vicinity of this, in such a way it is intersecting like this. And the circle is passing through the origin, as you know. And perhaps this circle is intersecting at 4 points. We don't know, because we can see here there's a some kind of situation here. One point is origin, one point is A here, maybe B here or C here, I don't know. So these are 4 points. We will see whether the 4 points are possible or not. And that is why it is important to transform the geometry into algebra, so that we can confirm by solving an equation that whether the 4 points are possible or not. Because if there's a 4 point, there are 4 points, we will have a biquadratic equation. So the plan is like this. We know that the parabola focal chord length is this one. Length of focal chord of parabola is given by A 1 by t. If I find out the value of t, we can use this formula. A we know, and we are done. Our aim is to find out the value of t. Of course, when we substitute this, x is equal to 8t square, that is 4t square, and y is equal to 8t. In this circle equation, we get all the possible values of t. We identify such t which will follow the property of the focal chord. And what is the property of the focal chord? That suppose we are getting 3 different t's or 4 different t's, I will take that pair which will produce the t1, t2 is equal to minus 1. That is the one property of the focal in mind. What is that? T1, t2, minus 1. And that is why this t minus 1 by t the whole coming. So it is not necessary to get the different t2. We simply choose the one end of the focal chord as for t, and then we will. So this is the plan we have. Just find out the values. Substitute x equals to 4t square, y is equal to 8t. So I'm substituting x equal to 4t square, so it will give you 16 to the power, and y is equal to 8t, so that will give you 64 t square minus 29 times 8t square, that is 4 minus 8t. From there you can notice that I can take t common, so 4t common rather, so that our life will be simpler. So it will be 4t common. It will give you 4t cubed minus 16t minus 4t common, so 29t, and here we get is equal to 0. It means what we get here, the 4t times 4t minus 45t minus 6. Once we get this thing, what we can now do, we will try to solve this equation. So once this t is equal to 0, we know. Now we have to evaluate the 4t cubed minus 45t minus 6 for t, what we have to do. So what are the solutions of this cubic equation? We have to now notice one important thing. This biquadratic, if you want to transform into simpler one, what we get? Minus whatever you get here, that we get plus minus t square. You notice one important thing is happening over here, that this equation has no cubic term, and it will be always there, because whenever such situation will happen, the circle equation has x squared plus y squared plus 2gx plus 2fy plus c kind of format. So for note, you notice one thing. The circle equation, x squared plus y squared plus 2gx plus 2fy plus c is equal to, and the parabola equation y squared, standard form I'm. So whenever you substitute the x equals to at squared and y is equal to at, do you get the cubic term of t? Of course not. Wherever you substitute here, that will produce the power 4. That will produce the power 2. That will produce the power 2. That will produce the power 1. That is constant. So we can see that the coefficient of the t cube is 0. What does it mean? The coefficient of t cube 0 means that 0 means that is what? That the sum of the roots, what we are looking for, t1 plus t2 plus t3 plus t4, is going to be 0. And if you know this fact, what is the meaning of this? The parabola intersect with a circle, always there will be 4 points, and the sum of all those parametric points, the t, is 0. So this also helps to find out the roots of this equation. I need one more root here, so we can apply the this rational root theorem to identify whether there any rational root is happening over or not. So we can directly check t is equal to 2, because the rational root tells that 6 by 4. So 6 has factors 1, 2, and 4 has factors 1, 2. So possible root is 1, minus 1, and so on. So we check 1, so 1 will not work. What about 2? If we substitute 2, that will give us design this question. Oh, I think I've done. This is plus here, and 16 minus 29. This is going to be okay. So we fixed it. So let me just conceptually, there is no fallacy, only this kind of silly mistakes I do. 4t cube minus 13t. Now I have this thing, and we can notice that t is equal to 2 is satisfying, because t, if you substitute 8 for the 26, the t minus 2 is one of the factor, and the other factors are t 2t plus 1 and 2t plus 3. Since I have already solved it, that's why you know that you can find it not so difficult, because the rational root theorem tells that the 6 has 3 factors, 1, 2, 3, and the 4 has 2 factors, 1 and 2. So rational roots, the possible roots are there. That is going to give us either plus or minus by taking the ratios of these two, 6 and the factors of it, or plus or minus, plus or minus, or plus or minus 3 by 2, or plus or minus. So we have to check one by one. If you find the uh, two factors, we can find the remainder. Or if you are able to find out, you know that the t minus 2 is one of the factor, we can create the new factor of quadratic by dividing it. And let me just give you what minus 13. You know that t minus 2 is one of the factor. I need 4t cube. I will multiply with 4t square, and I extra have 8t square. I don't need square term there. I have to compensate it, so I will multiply with 8t. And further, I have minus 6 and I have minus 30. So minus 6 and plus, this will give you a factor. From this, I need two numbers whose product is, yes, see, product is 12 and some we can find. So what we discovered here, that t is equal to 2 and t is equal to minus half and t is equal to minus. Notice one thing, these two pairs are actually fulfilling the property of the focal chord t1 t2 is equal to minus 1. It means I will choose t is equal to 2 or t is equal to minus half. Any of them will give us the length of the focal chord. So this t is equal to minus 3 by 2 is not getting anything, and maybe t is equal to minus 3 or 2 is sitting over here, or maybe here, I don't know. Or maybe the focal chord will look like this. We are taking t is equal to minus half. The points what we get. So let's find the point also. So let's say A is what? At t is equal to 2. A coordinate is 4t square into, that is the 8t square, 280. 280 what I need? 2 into that is 60. This point is 60. On this transformed parabola, if they ask you the original parabola, we have to shift again. Please keep in mind. Since we don't have to find the point of intersection over here, that is why we can choose this method by transforming. And the other point, the end point may be anywhere. So maybe let's like this. We have this as the focal chord. Let's see. And we have to find. All right. So E I'm taking as 2 and the focal chord length AB given by A times minus is A. A is have plus 1 by 2. A t plus 1 by t the whole t 25 is. I hope you understood this method. Here one mistake I did, but actually it's not that much bigger. This because it depends. T plus 1 by t, the taking here, even t2. All right. So this is one method, but can we do better? Means can we think smartly by using the properties of the parabola and the circle and find the answer? Let's try to do it. So this is the second method, which we are not going to include any algebraic calculation. This is the second method in which again we draw the graph, and of course we are taking again the shifted one. So up to here we have to do the same thing by shifting the parabola and circle the origin. So this is the parabola I have, and maybe the circle over here, they are intersecting each other. Of course, that's one of them is an origin, and I don't know whether this is intersecting here or don't care actually. This, suppose this is the intersection point here, and this is the focal chord. So it seems like we are taking the vertical, but it's not like this. Try to understand. Let me just tilt it. This is the parabola here. We are taking this as a focal. You know this one story about the focal chord, one very, very, very famous property of the focal chord. Suppose I'm taking this as A, this as focus, and this as B. I know this thing. If I take the lattice rectum of the parabola, see the lattice rectum, LL dash, lattice rectum of the parabola, rectum, the parabola is 4A, and there's a very unique property which connects the length AF, BF, and the lattice rectum. What is that? You know that's a 1 by AF plus 1 by BF is equal to 2 by the L. L is the half of the lattice rectum. What is L? L is half of the lattice rectum, means the semi-lattice rectum. So if I just try to use the lattice rectum here, I will multiply and divide by 2 on the right hand side. And we get what? 1 by AF and 1 by BF is equal to, what is that? 4 by lattice rectum. And lattice rectum we know. What is lattice? Yeah, 4 into 8. That is going to be 1 by, what I need actually? We need the sum of these two pieces. This is AF and this is BF. I have to find the length AB by just adding up these two pieces, the AF and the BF. Isn't it? Yes. So if I get, because A I know, A is 4. So suppose I'm trying to solve this thing further, I get AF plus BF by taking LCM is equal to, sorry, divided by AF into BF, that is equal to what? 1 by A. A is 4 in this particular, because the parabola is y squared 16x. A is 4. So if by any chance AF plus BF, now I'm writing AB, if by any chance if I get AF into BF, my work is over. Because I take this and divide by 4. So can I get AF into BF directly? Now try to think. Here, you notice one thing, that these 4 points, 1, this origin, this B, let's say O, and this point here is are on the circle. Let's say this point is D. Can we see in the reference of this point focus, I can use the power of point for the circle. Now I'm not seeing the parabola anymore. I simply see that focus is on one of the chord of the circle. That chord is AB, because AB is also the chord of the circle. So if I use the power of point, what I'm using here? Power of point of the circle. And this is, I think, the class 10 property. So what we can write for this power of point, I can write the AF into BF is equal to, here AF, this AF into BF is equal to OF into FD. That is OF FD. And what is OF? OF is exactly the value of A, because this parabola and the ellipse circle are intersecting at the horizon. So this will give you A, that is 4. And what is FD? How do you find FD? You notice that it is the point where the circle hits the x-axis. So where the circle hits the x-axis, you recall the equation of circle is what? The equation of circle was x square plus y square minus 29y, 29x minus 3y. So let me write x square plus y square minus 29x minus 3y is equal to 0. And in order to find out the coordinates of point D, to find further the length FD, I can simply take the value of the x coordinate of the D, because they're on the x-axis. So we substitute y is equal to 0, and we get here x square minus 29x, which will produce the x and x minus 29. It means x is equal to 0, which is actually giving us the reference horizon, and D is 29, 0. Now, what is the length FD? The length FD is the OD minus OF. And OD is, now we know, that is 29. OF is 4. So we get it here, 4 into 25. And that I have to substitute at the place of AF into BF. And therefore the length of the chord, what we are looking for, is 4 into 25 by 4. And so the answer is. So this is the way to solve this problem by PowerPoint. Designing this kind of questions a little bit challenging, because we have to keep the data consistent so that the student will not get troubled with some weird kind of situation, calculation root and all those. So here it was a little bit challenging for me to calculate. But anyway, we successfully did it and understood every concept. So first takeaway is that wherever they're demanding the length of anything, and it is actually easy to shift the system, we can shift it and we can find the length in this. The second thing is the power of point in this situation was very like a hidden gem. If we can identify, we can easily find it out. Even if you can find, if you are not shifting the system to the origin, still we can use the power of point there. The natural way, if you don't like to shift it, you can simply substitute it. Again, you can get the point and you get the same answer. Of course, you should get it. All right, so the answer is 25. Now we will see how this 4 points are actually, because if you draw the diagram without the help of any tool, you will never see that where is the fourth point in this situation. Maybe you are not shifting at the origin. Also, you can feel that where these 4 are there. That is why it is actually worth noticing in the GeoGebra where this 4th point is, or how this circle and parabola always intersects 4 point So the sum, oh, okay, the one thing I missed here, take your notice too, that you found the 4 points here, 4 sections, got t is equal to 0. You also got t is equal to 0 here. See that? 2 minus half and minus 3 by 2. If you add all of them, t1 plus t2 plus t3 plus t4, you get 0. You see there. T1 plus t2 should be 0. So they are intersecting at 4 points. All parameters. Let's dive into GeoGebra. They intersect. Go to the okay, so we are here in the GeoGebra and we draw the graph of the given parabola. That how parabola y minus 2 in times x minus the parabola, and now forty-five x 7y plus 1. You notice there's a very actually intuitive section here. They are intersect at the vertex of the parabola and one more 4 comma minus this original system. And there's one point here 12 comma minus and this 19. They will I don't, perhaps this will provide us this point the intersection of the x-axis. There's a rare chance that this two are the points. There's intersection. Now let's try to uh, do that circle when shifted one. But anyway, let's find it. Let's suppose taking the intersect and then find the length. Intersect here. That will provide every such ABC and all. And I want to find providing us E and D, that is 20. My guess was incorrect. That BD is this length segment BD. That gives you this length BD, and that is the length 25. So in this scenario, you get that the same thing. If you want to find out graph of y square is equal to shifted version, y square is equal to, and the circle was square y square minus 29y See that again the similar situation one in here, and again from there whatever the intersection is happening, that will be, because 4 comma 0 is the focus, so it pass through. This way we can visualize this whole thing. If you have enough time to explore things in the early stage when you are seventh, it will be very very beneficial. You internalize every concept in your mind and then you can play with questions. All right, that's it for today's video. Till next video, stay math active.